Okay, so we've been working on our inference, working on making an inference, right? So today what we're going to do is we're going to continue to the next section of our paper, which is going to be the analysis section. In the analysis section, you're going to be looking at several different pieces. I'm going to tell you which pieces you need to use. There are more analysis parts that you could use, but we want you to stay focused on the ones that are the most important. If you want to add in another one just to make sure, that's fine, but generally adding more is not as good as just doing a quality job on fewer, all right? So you need a minimum of 3 pieces of analysis. And if you just use the ones we talk about, then you'll have that template. You'll have a good idea of what it is you need to write about and what it is mathematically that you need to do. Now, you will have an exemplar. You will have the template that we use. Do not copy and paste. Last time, some of you copied and pasted things straight from the exemplar, and the numbers were wrong based on your data. This time, if you do it, we are going to categorize that as plagiarism, and you will get not achieved. So, last time, you just didn't get that section as correct. But this time, it's going to be plagiarism, and you're done. So be careful. We're having a real focus on plagiarism at the college right now because it's happening so much. So be careful in all your coursework, by the way. All right. So today what we're going to do is we're going to talk about something called shift. So again, we're going to look at 3 different types of analysis, and shift is one of the most important ones because it gives you a great deal of detail about the 2 sets of data that you're comparing. Okay? So we're going to be talking about shift, what it means, how you're going to describe it, and what numbers you need. Because remember, this is a math class. So you can say that there is a shift, but if you don't tell us by how much or what the numbers mean and what the numbers are, then we can't give you credit for it, right? So pay close attention to the way we're going to be describing the shift in this case. Okay? So we're just going to go to Education Perfect, everybody's favorite, and look at it. Okay? So, first thing, shift deals with the median. And remember that your very sentence, your sentence is, I wonder about the median, right? So if you don't mention the median or compare the medians of the 2 sets of data, then you're not answering your question. So your inference is completely wrong. So that's one of the reasons we choose shift. It also deals with what's called the quartiles. And you may remember there's a lower and an upper quartile, and we'll talk about that and see how each one of those is done. You do not have to do the math for that because, remember, you're going to put these in as a grapher, and it gives you that summary in red, those little red numbers. So you have all of those numbers with you. Okay? But you must relate your observation back to the context of the investigation. What does it mean that the median is here? Right? What does it mean that this median is so much bigger than the other median? In context. And so that's what we're going to focus on and how what we're going to talk about today. Okay? All right. So let's start looking at it. So again, this is working with the analysis section. So if you look here, we have 2 box and whisker plots. And as you can see from their graphics that the pieces of the box and whisker plot can shift right or left. The whiskers can get longer. The box can get smaller. The box is going to be the same. What's that thing in the middle that's moving about? That dark line in the middle, do you remember? It's the median. Yeah, that's the median. And notice that the median does not have to be in the center of it. So if you think about this box down here, this box and whisker, this one is perfectly symmetrical. That's very unusual. Usually, your median is shifted, is somewhere else in the box, and your tails, your 2 whiskers are different lengths, right? So they're usually not so perfectly aligned. So what we're going to do is we're going to learn about what each piece of that is and what that box and whisker plot represents. Okay? All right. The first thing you need to remember is all the pieces of a box and whisker plot. And so you have a minimum, simply means the smallest number. And again, the minimum will be listed on your summary of stats. You have a maximum, which is the largest value, and you're going to have a max on your list of stats. You have a median, and then you have what's called the lower quartile and the upper quartile. Now, when you do this with NZ Grapher, it just lists that as as LQ and UQ. Not too big of a stretch, though. Yeah. Right? And these pieces are really important when you're doing your analysis. These are the things that you're going to use to make sure that your analysis has meaning and is not just a jumble of nonsense. Okay? So, minimum, maximum, median, lower quartile, upper quartile. You won't have to do any math to find these. NZ Grapher will put it all together for you, and it'll even tell you the numbers for them. But you have to be able to use those numbers in context to answer the question. Okay? All right. And so we're going to talk about how those things move about, and when you're comparing two sets to see how the two sets of data differ. Okay? So if you look at these two distributions, the first thing that they didn't talk about a little bit, I want to mention really quickly, is that each one of these sections represents 25% or 1/4 of the data. Now, that might confuse you a little bit because they're all different sizes. But that just means that the values here are spread out. So you might, but there's still 25% of the data here. This is a big section, but 25% of the data is there. These are getting smaller. So what that means is there's still 25% of the data there, but the numbers are all very close together. And here, because if the section is spread out, then that means the values you have are more spread out. Okay? But each one of those represents 25%. That's why they're quartiles. So the median to the minimum is 50%. The median to the maximum is the other 50%. Right? 2 quartiles. See how that works? And so since this is 2 boxes, that's 50% of the data. Whereas that would be 25% at the end and 25% at this end. So do you see how it works? So you need to think of them as being combined in some cases. This bit in the blue here, that 50%, is what's called the interquartile range. And we'll talk about that quite a bit. And it represents 50% of the data. Right? So keep in mind the percentages. You're going to need to talk about those percentages. 50% of the data from this group is above such a percent in the other group. So that's part of the analysis that we're going to be doing here. Right? So in the following distribution, the median of the purple group is less than the median of the blue group. Do you see that? The median of the purple group is less than the median here. Less than because these things are just like on a number line, so it's far to the left. Yeah? As a matter of fact, that median is also lower than the lower quartile here. Do you agree? And these 3 boxes represent how much as a percentage of the data in the blue box, in the blue section. 1, 2, 3 of them, so that's what? 75%. So we can say then, from just looking at it, that because this is this much, that 75% of the blue data is bigger than 50% of the purple data. You see where I'm getting that? Because this value is bigger than the median. So it's bigger than at least half of that data. Now it's slightly more, but you don't know where that line is hitting. So we can only talk about things that we know the values of, right? So 75% of the blue data is above 50% of the purple data. So if you were talking about heights of students, this was the height of the class next door, and the blue was this height, we could say that 75% of the people in this class are taller than 50% of the people in that class. So 3/4 of you are taller than half of that class. Make sense? And so that's the kind of comparisons that we're going to be looking at. So think about how much further this value is from the median of the other value. And we always go from the median. All right? So let's look at some of this. So if this distribution was out scores of 2 tests, it would be valuable to notice that 50% of the students scored worse on the purple test than they did on the blue. So you can do the other way around too. So these guys, 50% of them did worse than on the purple test. Okay? Because the median was lower. So you can do different values. And so this is what's called the median shift. If the medians are not exactly the same, then that means they're either shifted to the right or shifted to the left. So we can compare, looking to see how the median of one sample group is shifted relative to the median of the other sample group. So if you look at these two samples, first of all, remember that the median is the line in the middle of the box, or inside the box, not in the middle. That's a bad definition, but in the box. And you'll notice that for those that did not smoke, the median is higher, right? Okay. Go up. Oh, you're trying to read the bottom? Okay. Oh, I see. Okay. There you go. Okay? No biggie. So you'll see that this median is to the right of the other median. So that means it's higher. And so just comparing the medians for mothers who didn't smoke is higher than the median birth weight, because it's birth weights here, median birth weight for those the mothers who did smoke. Okay? So this group of babies weighed more than this group of babies. Make sense? Now, this is the lower quartile, which means that 75% of this data is bigger than, that's the upper quartile. So that's 75% there, and this is 75% there. So 75% of the data here is bigger than 75% of the data there. Do you agree with that statement based on just those distributions? And if that's true, that means that we can be pretty confident that smoking is having an effect on the birth weights of these children. Because 75% is a lot, isn't it? Now, if it was only like 10% and 10%, that's pretty close together, so it'd be harder to say, right? But if you get a 75% difference, then you know you're onto something as far as your inference is concerned. There is definitely an effect happening here, right? Because 75% difference is quite large. And so we're going to see how to write that up and how to talk about that. Okay? Okay? All right. So to investigate median shift, you can simply look at how the median in one group is shifted relative to the median in the other one. So this median is shifted to the right, therefore this median is higher. Because again, remember that we're measuring on a number line. So the further you go right, the higher the numbers get. Okay. So what that tells us in context is that the median mother's age for non-low birth weight is greater than the median for low birth weight. So the median mother's age, because they were doing age here, I'm sorry, mother's age by birth weight. So these are the birth weights, and these are measuring the ages. I had it backwards because we were looking at the other way the other day, so it doesn't matter. But you have to talk about it in context. So here they're talking about the 25%. Everything's always divided up into quarters. Okay? And you're going to be comparing where these end. So this graph ends before you even get to the upper quartile. So that means that 25% of this data is bigger than 100% of that data. Do you agree? So it's just a matter of reading it and thinking about the shifts. Then we'll talk about how to write it in a bit. So here they give you a little animation. If the two quartiles are within the same range, then there is no quartile shift. But if one of the quartiles is shifted above or below the other by a full measure, so I'm just going to stop this here. So All right. There is no quartile shift here. Even though, even though this quartile is further over than this one, right? They still mostly overlap. Do you see that? The only time you would say there is a quartile shift is if one of these measures, the median or the lower quartile, goes beyond the median of the other. So let me show you what that looks like. Okay, oops, sorry. I'm trying to catch this one. All right. So do you see now this median is bigger than the upper quartile? That tells you that there's a quartile shift. So the median is bigger than the top of that. So the middle of that one is bigger than the top of the other one. That means there's a quartile shift. Just having overlap doesn't mean shift. One of those measures, and it's always the median has to be outside of the quartile of the interquartile range of the other one. So do you see that this median is further to the right than the upper quartile? That's the definition of quartile shift. Okay? Now it can be much bigger, as it was on some of the others, but you don't have a shift if they over, just because one is further than the other, only if one of those major measures is shifted. So be careful when you're describing this. Do not describe quartile shift if there's not one. All right? Now, again, we talked about this one, about the 75% and the 75%. This is a significant shift. And this is about the only one that you can say with certainty that there is enough shift in this one to say that your question can be answered. So there is definitely an effect here because 75% of these values are bigger than 75% of these values. So 3/4 of these are higher than those. So there's definitely an effect happening here. Now what if it was 50% versus 75%? It's pretty strong inference there that something is happening, but you can't be as certain. That 75% is the magic number when you can say, yes, something is happening. Other than that, you have to talk about it in terms of it appears that there are, and then use the numbers to justify it. And again, we'll talk about these. So here we go. So which one of these shows a quartile shift between groups? The red ones, or the A or B? Either one of those show a quartile shift? Okay, so because we have this median, right? It's always the median, so we have this, all of this is bigger than this median. Yeah? So that would be showing a quartile shift. So it's always looking at the median. So don't always look at the bottom median, look at both medians. Do you see that this lower quartile is above the median of this one? Yes? That means there's a quartile shift here. Here, this thing, the bottom of it is not above the median.
So does the lower quartile have to be bigger than the median?
Yes. Or one of the medians has to be bigger than one of the quartile measures. So if this line had been here, this would be demonstrating quartile shift based on that. But it's a median, it's always a median compared to lower quartile or upper quartile.
Okay.
All right? So if the median is above or below one of the upper or lower quartiles, then you're showing quartile shift. Right? It's always median compared to upper or lower quartile. Okay? All right. Okay, so here we are. Consider the graph showing house prices in Melbourne and Sydney. So in this case, they're not significantly different, are there? So could you say there's a quartile shift here? No. So, but that's not what they're asking, but you can definitely see that the two medians are in overlapping sections. They're not one below or above the other. So they're just asking you to read values from this. So this is when you're working. You just read the values. So you're going to practice finding the numbers, because if you don't include the numbers in your data, then your data is not good. So let's talk about how you're going to write it up. Okay? So first of all, you're going to make your observation. State your observed shift. The blue one is shifted to the right of the whatever. Okay? Then you're going to have to provide evidence. You must provide numbers from the summary to back up the observation. If you have the correct observation but no numbers to support it, that's achieved, but it's nothing else. Okay? Then you have to relate it back to context. What does that mean? That means 75% of the babies who smoke are boxers or whatever. Just I'm trying to see if you're awake. Okay? So just make sure you relate it back to the context, to your question. What does that do for you and your question? Okay? So let's look at an example. Here we go. We have number of pens by gender for males and females. Females seem to have a lot more pens than the males. So do you see that the median for females is above the upper quartile for the males? That means there's definitely a quartile shift. Yes? So look at how they've written it. The median for females is shifted to the right of the median values for males. The median value for females is 4 pens. This is 1.5 greater than the median value for males, which is 2.5 pens. So do you see that they gave the number and the difference between the two? So it's critical you include some math in this. This means that the median number of pens owned by females is greater than the median number of pens owned by males in this sample. You're going to see anytime you're dealing with an analysis, you have to talk about this being in this particular sample. That's what it's true for this sample. That does not mean it's going to be true for every sample. Okay? But for your particular sample, this is true. Right? So again, you're going to have this a template. Here it is, where they break it down. So this should be copied into your Word document so that you have this piece. The median value for females is shifted to the right or the median value of males. You must state, if there is a shift, what is it? Right? And you must be talking about the medians. Talk about the medians. Now, if the median value for females was shifted above the upper quartile for the males, then you wouldn't put median and median. You would say median and upper quartile, which is even bigger shift, right? So be specific, but make your observation about the shift. Then you're going to back it up with evidence. You need the actual numbers. Do the numbers make sense? Then you're going to relate it back to the context. This means that the females on average had more pens than the males in this particular sample. Okay? Now, the second part of this is talking about significant shifts. So that's what I was just mentioning. So this one, just the median was bigger than the other median. So you know that there's still shift there. But look at this one. The upper 50% of the data for females is greater than the lower 75% of the data for males. So in other words, the median of this one was bigger than the upper quartile of the other one. So this is a bigger shift, a much more significant shift. So in that case, you can talk about it as median and upper quartile because we know that that's 50 or 75%, but it gives more impact if you talk about the percentages. So the median values for females, and here they're talking about it in terms of, so here they're talking about it in terms of percent, here they're talking about it in the names of those different sections of the box and whisker plot. And then here, repeating the 50 and 75 as it relates to the context. Keep it simple. There's no reason to go off at the deep end when you're talking about context. Just state clearly and simply what it means. Okay? All right, so make sure you copy that. Here's another one. Here's the median for Jenkins, and is right at or slightly above. What we can do to check if they're this close is just go to your summary statistics on the side here, because it's very difficult for us to tell if this one is bigger than that one or if they're exactly the same. Right? So go to your summary statistics and find the median for the top one is 4, and find the upper quartile here, which is also 4. So they are the exact same, right? But remember, these are boundaries. So that still tells you that this is 50% of the data, and this stuff is 75% of the data. So in this case, Jenkins is 50% of the Jenkins data is bigger than 75% of the Thompson's data. So even if they're the same boundary point, that means the values are, the amount of data is still going to be the same. So even if the boundary is the same. Okay, so let's look at how they wrote that up. The median value for Jenkins is shifted to the right of the median value for Thompson. So here they're just talking about the medians. And they give the medians and tell the difference. And then they talk about, because this one had significant shift, that you get a second paragraph. So it's not one or the other. You must talk about the comparison of the medians because that's what your question asks you. But if there's significant data shift, you need to talk about that. Okay? And again, they just do a little recap. So you're going to have some exercises here where you're going to be describing these. They're on your Education Perfect, so just take the rest of this time to work through these. Make sure that you are really paying attention as you go, because you need to make sure that you're writing these out very carefully.